Hello everyone, welcome back to Pavani Teachers. Today in this video let's discuss Kruskal's algorithm and Prim's algorithm. Okay. First, these two are used to find minimum cost of spanning tree of a graph. Okay. I'll discuss the concept by using a problem. First I'll discuss how Kruskal's algorithm works. Okay. I'm taking the graph as this. First, while solving the Kruskal's algorithm you have to write. First step one is write all the weights of the edges. Write all the weights of the edges in ascending order. Okay. Then after writing all the weights of edges in an ascending order, you have to connect them from the least edge. Like if suppose here it will be like 1 2 3 I'll explain it later. Okay, like this we'll get some numbers. First we have to take the one weighted edge, that is A and D. You have to connect it like this. You have to connect all the edges, but it shouldn't form cycle. Here cycle means closing part. If it is closing, if the graph is closed, this I'll explain it. This part is known as closed. That means we didn't have any open space. The same if the graph is like D, E and F. This type of graph is called, it is not closed. It is not cycled. It is just a spanning tree. This type of closed thing is known as cycle. Okay, it shouldn't form the cycles while connecting the edges from the ascending order. Okay, that was the step of second. Step 2 is to connect the edges without forming edges of ascending order without forming cycles. Okay, that's it. You have to repeat all this process until you connect all the vertices that is present in the graph. Then you have to calculate the total weight of a graph. Okay, just simple 3 steps to solve Kruskal's algorithm. Okay, calculate the total weight of spanning tree. That's it. These are the main 3 steps that you have to follow while solving this Kruskal's algorithm. Now I'll explain how we have to solve this. Okay, now I'm writing all the edges in ascending order. I'll rub this. First one, that is A to D1. I'll write here A to D1. Then you have to check with the next number 2, that is C to F 2. Then we have 3. You can write anything at first. B to E 3, B to A 3. Then it is 4. D to F is 4. Then again 5. We have 2. You can write as same as before. You can write any edge at first. B to D 5 and D to C 5. And then next number is 6. Also here we have three edges with weight of 6. You can write any edge at first. E to D 6, E to F 6, A to C 6. I think I'm done with the writing all the edges in ascending order. Okay, in ascending order. That's it. Now after writing this, I'm actually explaining in a single step, but if you are writing your examinations, please put it in a step manner. Okay, here I'm explaining in a single graph. Okay, first while solving this step by step, after this step you have to write all the points like this. Like you have to plot all the vertices A, B, C, D, E, F. Okay, in their places. Then after plotting it, you have to start from this smallest weight of a edge, that is A to E, A to D. we have to connect this. This is the step 1. You have to draw it separately while you are writing in your examination. Okay. A to D, it is 1. Weight of edge is 1. Yes, it is not forming any cycle. Okay, we are taking that edge. Then it is C to F. C to F. That means this 2. Yeah, we are connecting this C to F. Now we'll take 3. That is B to E. Yeah, we'll connect this because it is not forming any cycle. 3. Okay. Next, B to A. B to A. Yeah, we can connect this because after connecting this, we haven't seen any cycles. So 3. Next, D to F. D to F. D to F. Yeah, we can connect this because it is not forming any cycle. So we can connect it. 4. Then next, B to D. B to D. B to D, that we cannot connect. As before I said, it shouldn't form cycle while connecting. So we are not taking this. Okay, I hope you got it. I'll explain it. If we take B to D, it will form a cycle which is not there in our algorithm. Okay, so we are not taking this edge. Then what was the next? D to C. D to C, yeah, even it is forming the cycle if we connect this. So we are not taking this. Then we'll go with the further. E to D. E to D. We cannot connect because it is forming cycle. So we are not taking this edge. Next, E to F. E to F. E to F. No, we cannot because it is forming cycle. So we are not taking this edge also. Next, A to C. No, we can't. Again, it is forming cycle here. Okay. So this is the final spanning tree of the given graph. After getting this final output, we have to add all these edges weight. That is as 3 plus 3 plus 1 plus 4 plus 2, which is equal to 13. So 13 is the minimum cost of spanning tree for the given graph. Okay, this is how Kruskal algorithm works. It is very simple. Just first write all the edges in ascending order weights, then just connect the edges without forming cycle. You will get a spanning tree and just calculate the sum of all the edges which are there in a spanning tree. Okay, this is how Kruskal's algorithm works. Now I'll explain with Prim's. Yeah, here is the example that I am taking to explain the Prim's algorithm. Okay, first I'll tell what are the steps you have to follow while solving these Prim's. Okay, the step 1 is you have to choose a source node or edge. Choose source edge, I'll say it, and this edge should be the smallest edge, weighted edge of a given graph. Should be smallest weighted edge. Okay, then you have to connect the adjacent edges which are having the less weight. You'll get to know what is this point while solving it. Okay, you have to connect the adjacent less weighted adjacent edge. Step 2, connect less weighted adjacent edge. Okay, and even here the cycle shouldn't form. Okay, cycles shouldn't form. At last you will get the spanning tree and just add all the weights. Then you will get the minimum spanning tree cost. Okay, now I will go with the explanation part of these steps. First, as I said, we have to take the least weighted edge. Here it is A to B. So I am taking that edge. Yeah. Please write all the steps differently while attempting in your examinations. Okay, I am taking A to B, that is as 10. Then after taking this, you have to choose the least adjacent edge, means which is having the less weight. Here 25 and 28. Here this 25. This A to E is having the less weight. less adjacent weight of edge. So we have to take this edge. Okay. So I'm taking this A to E. 25. Okay, we are done. Then again we have to check the next connected adjacent edges. Here we have 28 and here we have 24 and 22. We have 3 options. You have to check with every vertex connected edge. Okay, we have to check with B, we have to check with E, we have to check, that's it. Also if there is another edge with A, we also need to check this with the A also. As here we are having some connections with B and E, I am checking with these two. Here we are having 28, 24 and 22. As 22 is the less weighted edge, I am taking that edge here. 22, that's it. Then as we go forward, now we have to check with the connection with the F vertex also. Here we have options as again 28, 24, 18, 12. As here 12 is the less weighted adjacent edge, I am taking that edge 12. Okay, I hope you got it. Then again we have to check with the like the possibility connected edges with the G also. Now we have possibilities are 18, 16, 28 again here and 24. Now we have to check which edge is having the less. Here I could find it is 16. We have the options as 28, 24, 16, that's it, and 18 also. As 16 is the least weighted edge, connected edge, I am taking that 16. Okay. Now again, now in this time we have the possibilities to check the connected edges is 14 also here. So again I am checking what is the least weighted edge that is connected to the vertices. That is here the possibility is 14, which is D. So I am just taking this D 14. Okay. As we cover all the vertices that are present in this graph, it is completed and we got the minimum spanning tree. Okay. Now after getting the minimum spanning tree, if you go further, it will form circles. So while it is forming cycles, you better stop before the step. After getting this minimum spanning tree, you have to add all the weights that are present here. So here 10, 25, 22, 12, 14 and 16, and the total is 99 units. Okay, this is how Prim's algorithm works. In a shortcut, I'll explain again. That is, after giving a graph, just choose the shortest edge and start from there and connect all the adjacent edges. No, not all the connected edges, but the smallest connected edges of vertices that are already taken. Okay, then once you reach the minimum spanning tree, just add all those weights and you'll get the minimum cost of a spanning tree. This is how Kruskal's algorithm and Prim's algorithm works to solve and get minimum spanning tree cost of any given graph. Okay, thank you for watching. Please do subscribe for further information.